In this video, we will prove Bernoulli's principle through two experiments. The first one being the straw mister experiment that will be done by myself, Christina Isa, and by Tony Flutie. And the second one being the blue triangle straw experiment that will be done by Munir Ghassan and Mark Shah.
Hello, my name is Tony Flutie, and for the straw mister experiment, we're gonna use a glass of water and a straw cut in half. First, we insert the first half of the straw in the glass of water, and using the other half, we will blow through it. As we blow through the straw, the air rushes out with a great speed, so the air goes over the other straw with even greater speed. According to Bernoulli's principle, as the velocity of the fluid increases, its pressure decreases. The decrease in air pressure over the straws and the water causes the surrounding air pressure to push the water up through the straw, creating a mist. The faster moving air creates a region of lower pressure, and water is drawn into the low pressure area, resulting in the mist. The same principle is applied in perfume, spray bottles, and garden sprayers.
The Bernoulli's equation is a statement of conservation of energy of a fluid in motion along a streamline. The equation of Bernoulli's is P plus half rho V squared plus rho GH equal constant. Now let's analyze the experiment. In the initial state, the straw is submerged in the water, so the system is at rest. Now let's assume that the level of water inside the straw is the same as the level of water outside the straw, which is H1. And here P1 is the atmospheric pressure. So the equation is P1 plus half rho V1 squared plus rho GH1 equal to constant. And since the system is at rest, so the kinetic energy term, which is half rho V1 squared, is equal to 0 since the velocity is negligible. When air is blown through the straw, there is an increase in the velocity V2. According to Bernoulli's principle, an increase in velocity corresponds to a decrease in pressure. Here the equation is P2 plus half rho V2 squared plus rho GH2 equal constant. P2 is the atmospheric pressure during the experiment, V2 is the increased air velocity, and H2 is the new height of water in the straw. The decrease in pressure above the water surface of the straw allows the atmospheric pressure to lift the water up the straw and create a mist. So, the potential energy term, which is rho GH2, represents the work done by the pressure difference in lifting the water.
Hello, my name is Mark Shah, and for the second experiment, we will be doing the blow dryer and the ping pong ball experiment. This experiment is a demonstration of Bernoulli's equation, which will help us to describe the relationship between velocity and the pressure of a fluid. In this case, air is the fluid, and Bernoulli's equation will help explain the behavior of the ping pong ball within the airflow. The materials for this experiment are a blow dryer and a ping pong ball. The blow dryer will be held vertically, and the ball will be placed slightly above the blow dryer airstream. The blow dryer creates a steady stream of air. According to Bernoulli's principle, as the velocity of the air increases, the pressure decreases. Holding the ball just above the airstream creates a situation where the air moving around the ball increases in velocity. As the air velocity increases, the pressure decreases, creating a low pressure area above the ball. The higher pressure on the bottom of the ball, where the air is not moving as fast, pushes the ball upward. The lower pressure above the ball sucks it into the airstream, creating a balance of forces that keeps the ball suspended. The ball appears to hover in the air, seemingly defying gravity. This experiment shows that the faster moving air on one side of the ball creates a lower pressure compared to the slower moving air on the other side. The pressure difference generates a net force that keeps the ball suspended in the air.
This experiment is related to several real-life examples, such as the aircraft lift. As air flows over the curved upper surface of an airplane wing, its velocity increases, leading to a decrease in pressure. The higher pressure underneath the wing provides lift.
I'm Munir Ghassan, and today I want to explain the experiment of the blow dryer and the ping pong ball. So, in the initial state, the ball is at rest. So when the ball is at rest, there is no kinetic energy. So the V1 is equal to 0. And when V1 is equal to 0, all this term is equal to 0. When the blow dryer is turned on, the blow dryer creates an airstream. This airstream causes an increase in V2. Okay, so V2 is the pressure of the airstream on the ball, and V2 is the speed of the ball in the airstream, and H2 is the height of the ball in the airstream. So when V2 increases, P2 decreases. When P2 decreases, the pressure above the ball is less than the pressure below the ball. So the change in pressure causes the ball to rise in the airstream. In other cases, we have in the inclined case where we have an angle alpha. So the gravity becomes G sine alpha. In this case, the gravity decreases. So the height increases. Thank you.